And it's now open.
All right. Hello, everyone. Thank you for joining us today. We're going to wait a couple more minutes, maybe 1 or 2 more minutes to let people join before we get started. All right, it is 11:02 and I see that the meeting is well attended. We have a pretty full list of those who registered. So I think that's a good sign that we will get started on time today. So my name is Gratian Quaid. I'm the Director of Communications at Mercator International. And I'm very pleased to welcome you here today to this press briefing, which is hosted here in Toulouse, France, at the headquarters of Mercator Ocean International, which is the entrusted entity which implements the Copernicus Marine Service, which is, of course, one of the 6 thematic services of the European Union's flagship Earth observation program, Copernicus. And today's briefing will focus on a key annual delivery of the Copernicus Marine Service, the EU Copernicus Ocean State Report, and its summary for policymakers. This 9th edition will be published on the 30th of September. And this summary for policymakers, along with these press materials, are a prime example of how at Mercator Ocean and through the Copernicus Marine Service, we turn cutting-edge science from leading European experts and scientists and institutions into knowledge that not only guides policymakers, but it provides journalists with the most newsworthy insights on what's happening in our oceans right now. And complementing this work, we also produce weekly, monthly, and seasonal ocean bulletins, which feature updates on marine heat waves, sea ice, and other key ocean variables. And we provide interactive viewers, explainers, tutorials, and a wide range of resources that make the latest ocean knowledge accessible to journalists and decision makers on demand and throughout the year. So I'll walk you quickly through the agenda for today. It will be about a 1-hour press briefing. And we'll start with introductions from Richard Gilmore, Science Policy Officer, joining us from the European Commission at DG DEFIS. Then Pierre Bahurel, our Director General of Mercator Ocean International. Next, we'll move to a presentation on key findings from Karina van Schuckmann, who is a Senior Advisor and Chair of the Copernicus Marine Service Ocean State Report activity here at Mercator Ocean International. And finally, we will hand it off to a Q&A section. And it will be led by Laurence Collet, who heads our press relations. And just a couple housekeeping notes. This session will be recorded, and it will be shared afterwards with the wider public. Press releases are available in English, Spanish, and French. And we invite you to please type your questions in the Q&A functionality of this Teams tool. And then we will address all of those in the Q&A session at the end. So with that, I pass it off to Richard Gilmore. Would you please take the floor?
Well, thank you, Gracian. So yeah, my name is Richard Gilmore from the European Commission, actually from the Earth Observation Unit at DG DEFIS, which is responsible for the management of the Copernicus program as a whole. So it's a pleasure to have the opportunity to open this media briefing and the presentation of the 9th edition of the Copernicus Ocean State Report. So the Ocean State Report is an important report for Copernicus, the Copernicus program, and for the Marine Service. I think we can probably say it's one of its best sellers. It gives a sometimes alarming reminder of the pressing challenges facing our oceans, and it also represents a unique dashboard for ocean monitoring and an effective tool for communicating complex information about the health of our oceans. It is particularly useful for decision makers because of the way the information is presented in a concise and graphical way. This easy to understand presentation means that it is also accessible to non-specialist readers and the general public, making it a powerful awareness-raising tool. But it should also be noted that the information it presents is very robust, having gone through very rigorous scientific scrutiny. This means it is also an official reference report for the EU, presenting information that can be used for evidence-driven decision-making, for example, in the context of major marine policies such as the Marine Strategy Framework Directive, or, for example, by Eurostat to support some of the EU's reporting obligations, such as reporting ocean acidification for the UN Sustainability Development Goal 14. So in short, the Ocean State Report provides authoritative information to support major EU and international policies and initiatives and evidence-based decision-making for the oceans. And I would like to continue by saying that the publication of OSR 9 also comes at a particularly important time when it is essential to ensure that we have reliable information from a European source to inform environmental and climate policies. So firstly, almost not a day goes by without a headline on the accelerating impacts of climate change or some extreme weather event. And there is also a growing awareness that the ocean is very central to all these questions. We all know about sea level rise, but it goes far beyond this. For example, the critical role played by the oceans in the regulation of excess heat and excess CO2. Secondly, the oceans are currently very high on the political agenda. 2025 has been a particularly intense year. For example, this year we had the UN Oceans Conference in Nice. The European Commission unveiled the Ocean Pact there. And on this occasion, the European Commission, in partnership with Mercator Ocean and other Copernicus partners, presented our digital ocean pavilion. This allowed us to showcase many of the technologies underpinning the information that you will see presented in the Ocean State Report today. The Digital Ocean Pavilion also stimulated political interest at the highest level, for example, with a visit from President von der Leyen. Lastly, I would like to underline the current geopolitical situation, which highlights why it is so important for Europe to have at its disposal its own independent source of information on the state of the oceans to ensure the continuity of science-based decision support. So in short, I very much look forward to the presentation of Ocean State Report Issue 9 by the specialists themselves, and I would like to thank Mercator Ocean for its excellent work within the Copernicus program and the preparation of this Ocean State Report. Thank you very much.
Thank you so much for that. And with that, Pierre, our Director General of Mercator Ocean, would you like to please take the floor?
Good morning, everyone. Good morning, and thank you, Richard, for your words and the European Commission for its continued trust and support of the Copernicus Marine Service, which Mercator Ocean has implemented since it was created 10 years ago, more than 10 years ago, actually. I have three messages for you today. The first, and it has been mentioned already by Richard, this year is a special one for the ocean, but also for Mercator Ocean, the European Ocean Prediction Center. We celebrate this year our 30 years anniversary, 30 years of ocean prediction. And over these past 3 decades, we have been designing these digital ocean models to provide a complete and dynamic view of the ocean, from the physics of the ocean, the sea ice, but also to biogeochemistry and reaching out to marine biology today. And to give you an idea of the kind of super software that we operate, I mean, it's 30 ocean variables, temperature, salinity, currents, updated every 2 minutes on a digital ocean of 10 billion data points. So this service is offered in open access to 500,000 users worldwide. And this is open, this is free, and this is thanks to this European Commission support and idea that we need to share as soon as possible the ocean knowledge that is gathered by scientists. We also developed, it has been mentioned by Richard, the next generation in the form of this European Digital Twin Ocean, where we are adding to this core digital ocean interactive layers, inviting sectorial applications from coastal risk, nature-based solutions, the monitoring of marine species such as turtles, monitoring the fishing risk or tracking plastic collection, etc., etc. So to stimulate and help accessing this scientific information on operational basis. Now, looking ahead, this year also, the international treaty that will transform Mercator Ocean into an intergovernmental organization has been adopted in Nice in June and open to signature. So we are offering to the governments the opportunity, the European member states, the opportunity to join Mercator Ocean and drive this ocean monitoring and forecasting service. And it has been done at the UN Ocean Conference, but we will continue along the coming years to, I mean, responding to this high visibility of the ocean and high interest at the highest political level, and connecting science to policymakers. So Mercator will become an intergovernmental organization, and this will be the first and the only one dedicated to digital ocean knowledge. The second message is that today we introduce you the 9th Copernicus Ocean State Report with a super clear message. Every part of the ocean is affected by a triple planetary crisis: climate change, biodiversity loss, and pollution. So warming waters, rising seas, acidification, plastics, these are realities everywhere, and it is explained in this report. So every year we have this Ocean State Report, gathering expert knowledge on the ocean and translating this science into actionable information for policymakers. But in this context of a triple planetary crisis, it is more essential than ever to combine, to have this science plus operational capacity combined. And this is what Copernicus Marine Service offers. And frankly, this is rather unique, and we can be proud of it in Europe. And the third message is that this Ocean State Report is more than this. It looks at the ocean as a whole. What happens in the ocean matters to everyone, I mean, to society, to economy, to marine ecosystem at large. And in this Ocean State Report, this new edition, we are bringing all together these pieces and to give a clear scientific voice that helps make better decisions. I mean, connecting the different components that are necessary to understand what is at stake. So it is an evidence-based report that will help people to be better prepared. And because regular access to the latest ocean science is essential for effective and collaborative action. So I am proud, and at Mercator, we are proud to contribute to this collective effort with the European Commission, and happy to share this Ocean State Report with you today. Finally, let me thank sincerely the 70 scientists in Europe and experts who made this new edition. And it's my pleasure to hand over to Karina. She's our lead expert, our guide in this science policy interface at Mercator, and she will present to you the key findings of the new edition. So back to you, Karina. Thank you very much.
Thank you very much. So I have the pleasure to provide you an overview on the Copernicus Ocean State Report, what this 9th issue will provide you as information, and what are the implications. So what is the Ocean State Report? So the Ocean State Report provides the science-based insights in order to inform policy and creating public awareness, with the objective to understand the different processes and variations we observe and we model in the ocean, and to understand how this is proceeding. We do this for the different components of the ocean, from the blue ocean, which includes the physics, from the white ocean, which includes the part which are in the frozen parts of the world, in the cryosphere, or in the green ocean, which are the aspects of the biogeochemistry, but also on the biodiversity and marine ecosystems. So it's an ocean state report which provides a state-of-the-art reference for the variability and the changes and the state of the ocean, and with key inputs to support hence policies and also the general public. What we have to state here is also the report in numbers. So this issue here had been developed by more than 70 multidisciplinary experts, which are experts on these different aspects and dimensions on the ocean. It's consisting of 12 peer-reviewed publications in collaboration with the scientific journal of Copernicus publication, which is called State of the Planet. And it is done by in different countries, from scientists from different countries. So 9 countries have been involved for this issue. And we use a huge number of trusted products, ocean data from observation, satellite observation, from in situ observations, and from models, combining the observations and our theoretical knowledge through ocean reanalysis systems. So this is a comprehensive overview on how this report had been constructed. So what is the content of the report of the 9th issue? So the major message of the overall content of this report is that the ocean sustains life, and that those changes are happening, and that they affect us all, and also they affect the ecosystems and society and also the economy. So the content the gathers the analysis scratches from ocean and climate change, and touches also the implications for societal changes, for economic changes, and also the implications for marine ecosystem changes. So this is just an overview on the major long-term changes we observed. So we have from Richard and from Pierre mentioned one of the key pressures in the ocean is the implications from climate change. So as a consequence, what we observed is that the ocean aspects are continuing to accelerate, to increase, and to reach record-breaking changes in the recent years. And so, for example, we know that the ocean is warming and that the ocean is accelerating. Ocean warming is accelerating. We see that the ocean acidification is widespread over many areas in the ocean, touching all basins of the global ocean, and this is happening globally and hence regionally. Sea level rise is accelerating and is reaching record height values in the year 24. And we observe on both hemispheres, in the north and in the south, that sea ice is declining at record levels. What we also observe is that we see, as mentioned already by Pierre, if we look at the 3 pressures on the ocean, which is the so-called planetary crisis, triple planetary crisis of biodiversity loss, climate change, and pollution, we see the different aspects, how they are disseminated and visualized in the ocean. What is the imprint of those pressures? So what we see is the regional aspects of fast rising sea levels, ocean warming, and ocean acidifications, which occur in all ocean basins. What we also see is that endangered and critical endangered corals face combined pressures from rapid warming, acidification, and plastic pollution. What we also observe with respect to the biodiversity loss is that iconic species like tuna, they're increasingly vulnerable, and they're creating wider risk for marine food webs and nutrition. And we can also observe that the plastic waste from every continent is putting pollution into all ocean basins. So this is a clear picture of how the ocean is affected by the pressures of the triple planetary crisis. If we also look at ocean extremes, the ocean extremes which we observed, for example, in the report in this issue in the year 23 and 24, we could see that they reach record values, ocean extremes expressed as ocean heat waves, marine heat waves. And this has particularly been the case in those recent years in the North Atlantic. So, for example, in the Northwest Atlantic, we have seen that marine heat waves have been increasing in frequency and intensity over the past 3 decades, and that some of the strongest warming has been seen in some areas in the ocean floor. So it's not only a surface phenomenon, it's really touching the water column as a whole. So the Mediterranean Sea, we see that there was a rise of 16 to 23 days in marine heat wave conditions per decade, and we could also see that the surface temperature rose by 0.4 degrees Celsius per decade. Also, if you look at a closer look to the North Atlantic tropical ocean, we could see in 23 that the region experienced a record-breaking marine wave with new heights with respect to its intensity, the duration, and also the extent. It was a very wide-reaching event for this area of the Atlantic Ocean. What we could also see with respect to the ocean extremes, when we have a look on the drivers of what is happening with marine heat waves, we could also have implication on the decomplexity of the ocean to show how complex it is, and with a different analysis we could show how this is working. So we could show that in 20C, for example, for a specific area in the Newfoundland and Labrador Sea, that the combination of cold spring, a very seasonal aspect, the fresh surface, but also lower wind speeds, they reduce then the processes in the ocean, the processes how they mix and between the ocean layers, and this in turn leads to trapping heat near the surface and with them evolving into a marine heat wave. What we could also observe is the implication of unusual warmer conditions, such as, for example, the economic change with a warmer seafloor as from this event of marine extremes, which boost lobster catches in Nova Scotia and offering insights for more sustainable fisheries. So this is giving also insight on the long-term changes, like warmer bottom waters make lobsters more active and easier to catch. And they know that this knowledge can improve the stock assessment and support sustainable fisheries. And then we could also have insight in this issue with respect to a global view on the marine ecosystem change. What has been used here is one specific measure. It's a measure on the micronecton, which is a small but very essential organism, which is supporting food webs and carbon storage. And so we, in this issue, we could see how the implications of a warming oceans are on this specific element at the biodiversity, which is on the lower part of the marine chain, of the living chain, so which is having an impact that those areas are shifting and shrinking. So we could see, for example, that a warming ocean is causing the boundaries of marine biophysical provinces to shift toward the poles. We could see that coastal regions rich in marine life, fueled by rising and nutrient-filled water, that they have shrunk. And also in the Southern Ocean, we could see that the subpolar provinces has grown at the expense of the polar provinces. Also, specific studies have been done on the marine ecosystem changes with respect also to a warming ocean. So that warming seas fuel the spread of invasive species and also in turn disrupt marine biodiversity and coastal economies. So, for example, from May 22 to early 23, the Mediterranean experienced its longest ever recorded marine heat wave in the last 4 decades. And there was then hence a rapid population growth of invasive Atlantic blue crabs. This designated clam population in the Po River Delta, with production of falling by 75 to 100%. Also in Sicily, in the north coast of Italy, a rise of venomous beard fireworms threatened the economy of artisanal fisheries, and also had implications on human health and also on the marine ecosystems. And this specific event had been also measured that it had been risen, the temperature had been risen by about 4.3 degrees Celsius as compared to the normal, and attracting invasive species and hence disrupting then the fisheries. If you look at larger scale on combining the different information on the environmental changes we see in the ocean with respect to the indicators we have, for example, for the societal aspects, here we combine, for example, information on sea level change with the population density in Europe. And you can see the sea level rise events where the sea level rise is rising faster than the global mean trend. So these are the lines on this map. And you can see that those areas that all European countries with high population densities, which exceed, for example, 200 persons per kilometer square, near the coast are experiencing sea level rise faster than the global average. And there are also in dotted lines, you can see the coastal UNESCO World Heritage Sites, its locations, and also you can see that that those sites in low-lying coastal regions are also at risk from flooding over centennial timescales. If we look also on the aspects of implications like ocean warming and also acidification of the ocean, so we can see here on the ocean the areas in green, and for the fast acidification, this is where the pH is declining faster than the global trend, so it's getting more acidic. And also for the areas of fast sea surface temperature rise, which is faster than the global trend, compared to aspects like UNESCO World Heritage marine sites, with a rich unique marine biodiversity, exceptional ecosystem, remarkable geological processes, or unparalleled beauty, and compared also to aquaculture production at country level for Europe, which provide also the context to the economic domain. And these areas show that all UNESCO World Heritage marine sites in the northeastern Atlantic and adjacent seas face rapid ocean surface warming at rates above the global average. What we also show is combining here information on the employment and coastal tourism, and looking at the aspect or the evolution on the marine heat waves. And we also have an aspect on the biodiversity where we show information on seagrass and also cold water coral. These are all components of the marine ecosystems which are very sensitive to such temporal extremes in the ocean. And also studies have shown that there is a link between the occurrence of marine heat waves and economic aspects such as coastal tourism. So in 24, for example, there were severe and extreme marine heat waves which were lasting 5 days or more, and they hit waters with 70% of Europe's shellfish farms, and also countries where up to 80% of pure economy jobs depend on coastal tourism. Then finally, we're also looking at innovations and advancements on our combining our knowledge and combining the different techniques and the different data products, which are providing two aspects here, which have been presented in these issues, is a new framework to assess the physical state of the Baltic Sea, combining artificial intelligence with the different physical knowledge in order to provide a specific framework which provides relationships between the ocean state and the forcing like river runoff, precipitation, the wind stress, and also the salt transport in the Baltic Sea. And we're also looking at improving phytoplankton satellite observations with machine learning and new algorithms which provide an improved data sets of harmonized 20 years of satellite ocean color data. And part of the Ocean State Report, there is an initiative which had been launched on the World Ocean Day on the 8th of June. And this will be launched each year on the 8th of June, which is highlighting the complex relationships between the current state of the ocean and its interaction with human activities, working across 5 branches, providing insights on the ocean state, the protection efforts, opportunities for humanity, societal harms, and human pressures. And this is included also as part in the Ocean State Report. So what we also have is a synthesis of all this information where we combine, on the one hand, the data products from the different spheres, like the observations and the modeling, together combined with ocean knowledge, which provide us also an understanding what is happening and why. and an operation in regular manner, and together with a lot of experts, as mentioned before, in numbers, which in order to support sustainable ocean stewardship for environmental resilience, social equity, and social sustainability. So thank you very much, and I'm very much looking forward to reply to your questions and for you to explore the content of this report.
Thank you very much, Karina, for that comprehensive overview. And now we'd like to move on to the next part of our press briefing, which is the Q&A. Please feel free to write your questions in the Q&A functionality.
I can see that we have a question from Clara. Maybe Clara, if you want to open your microphone, your camera, you can ask your question or use the Q&A. It's up to you.
Hello, thank you. I'm from newspaper Público in Lisbon, and I would like to have understand better what are the causes of the marine heat waves, and if you have made a calculation of the how much the warming, the heat waves in Europe has cost the economy, the European economy. Thank you.
So thank you very much for this question. Yes, with respect to the causes of marine heat waves, so there are three major causes identified in general how they can affect marine heat waves. So the ocean is a very strong communicator with the overlying atmosphere. And so if there are specific conditions in the atmosphere, such as also a heat wave in the atmosphere or unusual low winds, this can give the conditions in order to an evolution of higher temperatures in the ocean. There are aspects with respect to have a remote contribution from, for example, a current, which has experienced unusual warm waters from a remote, let's say, sea interaction, for example, which can lead also to a specific marine heat wave. And there's also discussion of other aspects which are combined aspects and with some dynamical processes which combine also the lower part of the ocean with the upper part of the ocean, which is combining both the advection aspect, so like currents and other aspects, which water can move around, and the interaction with the atmosphere. With respect to the economic calculations, we do not have provided specific calculation in this issue of the report, but I take notice that this would be a very interesting aspect.
Thank you, Karina. We now have a question from Hortense, from the French Reporter Media Outlet. She would like to know if we expect ocean stratification to increase in the future, and with what consequences. And the second question is, if emission halted, would the ocean get better rapidly, or is there a lot of inertia?
So yes, thank you very much also for this interesting question. So with respect to the stratification, so stratification of the ocean, so the way of how the different layers are superposed, so let's say it's a very technical word, so I try to open it a bit, is dependent on its way of the temperature, how the temperature is calculated, and also the salinity, so which provide the density, and this then have a stable distribution of density. So yes, with the warming ocean, we see these changes, and what we know also from other studies and also what has been done in the last IPCC is that we observe an increase in stratification, which are the consequences. There are many consequences. Particularly, there are, for example, consequences with respect to marine biodiversity. Another consequence maybe I would like to highlight with respect to your second question is also that there will be an impact on the biological carbon pump, which means that the ocean will have reduced capabilities in order to take up carbon, for example, and distribute this into the deeper ocean because the stratification is stronger. And then to your second question with respect to the warming, or let's say the reduction of CO2 and its implication for the ocean. So there are many aspects in the ocean which will be reduced, which will be at timescales which will allow to have an improved condition of the ocean. And this is particularly the case for the part of the ocean, which is the upper part, which is, as I said before, a great communicator, communicating with the atmosphere, exchanging then also the heat with the atmosphere, and then getting to this regulation process. But there's also aspects of the ocean which have this type of inertia. This is particularly the case for the deep ocean. So everything which is below this active layer, which is communicating layer, this we get into timescales which are very long timescales of 100 to 1,000 of years. So some aspects of the warming will have a long time in order and will remain. So it's a kind of memory of what we are doing today.
Thank you, Karina. I have another question from Dominique Leglou. She is president of the French Association for the Advancement of Science in France. On the slide about phytoplankton, you show an image with NASA source. Which are the European satellites that are able now to follow the evolution of plankton, if we have this information available today?
Phytoplankton. I mean, with the we have of course the Copernicus program. So maybe Richard, you want to mention more on the satellite part of the Copernicus program, which is a big component of Copernicus. And so there is this aspect where you have ocean color measurements, and so which provide you then information on this information. But if you want to have more information on the satellite program, maybe Richard, you can comment.
And we can come back to this slide maybe about the phytoplankton with this satellite image. It's not a slide? Okay. Richard, do you want to take the floor and provide an answer today?
I mean, maybe it's not relevant here to launch into a general presentation of the entire Sentinel fleet serving Copernicus, except to say there are 6 main families looking at various aspects. But maybe coming specifically back to this image, it's maybe worth pointing out that we can't observe, of course, plankton from space, but we can derive that by looking at the color of the ocean. And we have one particular satellite which does that very well, which is the Sentinel-3 constellation. So I don't know, maybe Karina will certainly be able to explain much better than me how you convert ocean color into a derivation of what the phytoplankton situation is.
Okay, thank you very much. So
thank you, Richard. Okay, so next question is from Gustav in Sweden. The report mentions that around 200 million people live along Europe's coast and that many World Heritage sites are at risk. So if we can come back to this slide, which specific regions in Europe are least prepared to handle this acceleration? And what immediate measures are required to protect both the population and cultural heritages? Thank you, Gustav, for this question.
Yes, thank you very much for this question. So this is a very nice question which really demonstrated how this information can support and guide future decisions, future solutions. Because what we provide here is a regional overview on those areas, highlight those areas. So it's figure 4, please. Those areas which show a rapid sea level rise. So we give the numbers, and this can also help in order to think about long-term solutions and long-term strategies in order to prepare on the different changes in the ocean we observe today. and then also with respect to the decisions we take in the future with respect to saving the coastal heritage sites, but also infrastructures and habitat in Europe and abroad. I mean, this is just one focus, but sea level rise is a global phenomenon.
Alison from Reuters, I see that you have raised your hand. Maybe you want to ask your question and open your microphone.
Hi, thank you for this briefing. I wanted to ask a question more about how the ratification of the High Seas Treaty will change programming at Mercator or Copernicus more generally, if you have a comment on that.
Richard, will you start, or?
I'm unfortunately not so knowledgeable about that particular aspect, so we could offer maybe to do a bit of research and come back in writing on that particular topic.
In general, the report in the Copernicus Marine Service offers the base of data that can be used for all sorts of monitoring that would be key for this that particular treaty and others. And so this free and open data is a key underpinning source for following these types of policy initiatives. But for further information, we will, that is something that we're very keenly following here, and we'll be publishing and writing about in the future. So please stay tuned for that.
Another question from Natalia from the EFE agency. There is a reference in the report summary about the sea ice loss and the square kilometers less respect the long-term winter average. Can you please explain this concept?
The less respect. So I mean, what you can see. I mean, I have to look at the specific phrase you mentioned. But in general, what I can say is that with long-term changes, you have a superposition of different changes. So you have on the one hand a long-term change, and you have the seasonal variations, and you have also the variations which are driven by, for example, natural variations such as climate variability. I mean, it's not relevant now for sea ice, but to give an example for climate variability is El Niño, for example. And so these type of variations are superposed. So you see the long-term trend, you see the seasonal changes. With this respect, there are interactions on those timescales. For example, in the areas such as in the Arctic, are changes where you can see also changes in the length of the season, for example. We did not specifically tackle this, but that is an aspect we want to tackle also for the next report. And these are, for example, specific aspects which are really relevant also with respect to socioeconomic implications and so on. So this is a very important aspect to ensure to address the different complexities of the ocean, advance on this understanding, and develop them in a way and experiment in a way and link them in a way that they can be of importance in order to be applied for socioeconomic development of solutions with respect to those changes. I hope this replied to your question.
Thank you, Karina. We now have two similar questions, I would say, from Sandy Dauphin and also in the Q&A from Clara Barata. It's about was producing this report impacted by the Trump administration's cut in scientific programs and monitoring? And on the same level of question, how will the blackout in the scientific information about the climate and the ocean in the US affect the European knowledge about the ocean? Indeed.
So I think that it's very important that, for example, these results of this issue have shown that the ocean in particular, but it's not also the ocean, but that the world is faced to the triple planetary crisis, so meaning of climate change, biodiversity loss, and also to pollution. And these are all aspects which we could visualize and which underline the need to ensure that there is evidence-based and authoritative information available in order to support societies to adapt and also to reduce these aspects of the changes we induce in the world we create today. So it's important and underlines again as another aspect how to see these results and how to see these collaborations across countries, these collaborations across disciplines, these collaborations across the different dimensions of the data we use, which allows us to support the societies where we need in times where the world is under pressure.
To go back to the first part of your question, this report is delivered every year without any relevance taken to what's happening politically around the world. So it's something that we deliver with science-based, evidence-based information, and it underlines the importance that this regular and reliable report is released, and that the political questions are not associated with it.
If we go back to marine heat waves, I have another question about climate change and what does climate change play as a role in marine heat waves?
Yes, that's a very good question. And so one aspect is what is the role of climate change? Let's say, no, it's not. It's a question of how the oceans are warming. I mean, the consequence of having heat waves. So heat waves are also a natural phenomenon, let's say. But as I explained before, we have a long-term trend. This is acting on the natural functioning and interacting of the ocean and in the nature in general. And so the marine heat waves strengthen, they intensify, and they strengthen also in frequency. So why is the ocean warming? The ocean is warming because today, because of greenhouse gas emissions, the Earth is out of energy balance. And this means that less energy is leaving the system as compared to what it is receiving from the sun. And as a consequence, heat is accumulated in the climate system. And this is taken up by the atmosphere, by the ocean, to warm the ice and also to warm the continents. And particularly 90% is taken up by the ocean of this surplus heat we create from human emissions. So this is the direct link. So greenhouse gas emissions and the warming of the ocean, and hence the impact on ocean extremes as marine heat waves.
Thank you, Karina. We have another question from Dominique about NOAA. Does NOAA still send information, I guess, to Europe?
In this report, we use various set of data. So, of course, one of the major baselines, the data we use in this report are data from the Copernicus Marine and also from the Copernicus Climate Change Service. And we also use data in order to complement which are outside, and we have also used in this report a specific heat data from NOAA. So at the time of this report, this had been no issue, and whenever data are available, we have this approach to collaborate, to bring the expertise together, to bring the knowledge together, and combine with the elements we have, the more we will continue to do so.
Thank you, Karina. I have a new question from Rosa in Spain, Rosa Basterio, just trying to read it. Are we approaching a tipping point in the oceans? Do you have a reference threshold for the values studied, exceeding which would jeopardize the balance of the ocean? I'm sorry, Rosa, because the question is quite difficult to read. I don't know why. The format is different. And maybe my question makes no sense. Okay,
I got
perfect.
I think the direction,
Yeah.
but then you can correct me again if I should answer more. So the tipping points. You should know that tipping points is an element which had been detected, let's say, in models. And that there is still a lot of work which needs to be done in order to measure those tipping points, and also to particularly measure the pathways towards the tipping points. There are specific frameworks, which I would not call tipping point frameworks, but for example, a framework you mentioned, I think, with your second part of your question with respect to the planetary boundary systems, where there had been an approach done in order to define specific aspects of our planetary system, such as, for example, climate change, or such as, for example, ocean acidification, and And there's also one aspect on biodiversity, etc. I think there's 7 planetary boundaries, etc. So with the results we see today, so we didn't specifically put this into the context, but if we look at the values we obtain, for example, with respect to ocean acidification and this framework, we see that we are clearly approaching these planetary boundaries, so being in a safe space for humanity, how it is promoted, this planetary boundary framework. And what we also see is that we approach one of the 2 thresholds which had been determined for climate change. And this is the so-called Earth energy imbalance. And the Earth energy imbalance is provided by our sentinel, and that's the ocean, to ocean warming. And so that we are approaching also this value, which had been defined by this framework. But further studies needs to be done in order to give a clear indication and linkage on this framework.
Thank you, Karina. Another question from Gustave. If you could offer one urgent recommendation to European policymakers based on the result of the report, what would that be?
My urgent recommendation is to consider clearly the results we have demonstrated here with a lot of experts around the world on the status of the ocean, which is an urgent alert, but also which provides a lot of information which will help in order to take the decisions we need in order to protect the ocean and to sustain its life-supporting role. So this is a major aspect, to see what the results are, to see what the science tells us in order, and to use this information to ensure that the decisions and the future directions and strategies will be based on evidence.
Thank you, Karina. If you have any other question, we still have time. You can open your mic, raise your hand.
There's a question.
So maybe one from me, Karina, for you, for this 9th edition, because this is the 9th edition, right? So you have the long experience. What is the most striking, surprising, or maybe it's a bit similar to Gustave's question, but information or point that you have for this one, especially?
Yes, I would like to give a double answer here. So the first is that the 9th issue is really in continuation and is really moving to a robustness of regular reporting, of regular information, putting a strong community together, putting exchanges together, putting so many data sets together to not only provide a long-term monitoring and reporting on the ocean, but to ensure that we skip on the recent events which have been taken, which have been usual, to understand them, which in turn will help us also to anticipate better and to provide this comprehensive vision on the ocean. And the second part is also that this report, because we have managed also to combine different dimensions, not only the environmental dimension of sustainable development, but also society and the economy, that this is a really clear picture which provides us a kind of recipe which is coming back to the question before of what we have to do. So we have one glance of how the ocean, that every basin in the ocean is affected by the triple planetary crisis. This is also the recipe, what we have to do, that we turn the world we have created into something which will ensure that we protect the ocean.
Thank you. And another question is coming. Do you know why the Mediterranean Sea and the North Atlantic experienced such extreme temperatures in 2023 and 2024?
Yes, so this is coming to, let's say, one of the narratives which appears to be a narrative through my replies. So this is, again, we have the long-term trend. So we see the long-term trend, we see the warming of the ocean, but we have also a lot of variability. And particularly, there had been other studies coming out, and we also discussed this in our report, which show also different conditions which have been favored, such as conditions I explained with respect to the dialogue of the ocean with the atmosphere, where we had unusual low winds and unusual high temperatures in the atmosphere, which favored also the development. Then there had been other aspects with respect to volcanic eruptions, which took place remotely and which had also an effect of warming effect, because it had been specific aerosols, not the cooling ones. Then there had been also with respect to dust in the atmosphere. Then there had been also discussion whether there, and this is still a discussion, whether there is an implication on the long-term trend, whether this has been increased through an additional forcing in the system. That is, the forcing is a reduction of aerosol, because globally they have a cooling effect. So there are different discussions which show also the complexity of the system and why we have to continue to look at all of this in order to advance our understanding, which in turn will reply to your questions.
Thank you. There is another question about plastic pollution this time. So this year, countries twice failed to reach an agreement on plastic production and waste management. What information should they take from the report?
The message is clear. The message is clear that plastic pollution, but not only, I mean, also over-exploitation mentioned, I mean, it's part of this with respect to biodiversity loss and also the climate change are affecting the ocean, and they're affecting them in all basins. So it's a clear message that there is a need to reduce those pressures on our ocean in order to ensure its life-supporting role.
Thank you, Karina.
Thank you, Karina. And we're coming up at the end of our hour together. We wanted to also pass along a few more bits of information for your continued reporting. Of course, the Ocean State Report is an in-depth report looking at a one-year period with a long peer-reviewed process, but we also provide a bulletin which is released every week for marine heat waves, every month looking at ocean temperature, sea surface temperature and records, and seasonally for sea ice maximums and minimums in both poles. And so these are what you could even call more timely or up-to-date indicators that you can follow and report on what's happening right now in the ocean. So please know about this tool, which you can find the QR code here. In the press pack, there's the press release available in English, Spanish, and French. The summary is available, including the full report. The embargo for the entire summary and full report is on the 30th of September. So please be sure not to publish beforehand. In the press pack, you will also find a video, a promotional video, which talks about some of the key findings that's been used in some reporting in years past, images, and also regional deep dives. So you can see more about how specific regions, including Europe, Canada, the US, Latin America, have specific information highlighted from this report. And any further questions, we will follow up. Please feel free to contact our press email and Laurence Collet, who's in charge of press relations, and we will come back to you.
And just to let you know that, of course, we saw that the report has been written by authors in 9 different countries. So these authors remain also available if you have specific questions to different topics. And through the press email address at Mercator Ocean, we will put you in contact with them. Is there any last question you want to ask to Karina or Gratian? Otherwise, thank you very much again for joining us today. And again, I remain at your disposal for any further question and follow-up. Thank you very much, and I wish you all a very good day.
Thank you very much.
you.
Have a good day.